Okay, here's an example of how to graph of a hyperbola. So this will tell us right here, the 2 and the 1, these are the h and k, which are the centers. We have to be really careful because they go out of order. 2 goes with y and x goes with 1. So this center here is -1 and +2. Remember, because the formula is minus h and minus k, so these end up being the opposite signs. And then a is the horizontal distance, and that's the square root of whatever's under x. So the square root of 4 is 2, and b is the vertical distance, that's the square root of this 9. By the way, this is just an example, it's not from your assignment. So the way that we graph this is all we need to know to graph this. So we're going to graph a center at -1, and we're going to go up 2. And then a is 2. So from this center, we're going to go 1, 2, 1, 2, and put a point. And then we're going to go 1, 2, and put a point. This is a horizontal distance. So from the center, we went 2 to the right and 2 to the left, although it doesn't look very even. The height is going to be based on b. So it's going to go 1, 2, 3, put a point there. 1, 2, 3, put a point there. So we have b is 3, a is 2. And then we make this a box, and these ends up being the midpoints of the rectangle. And then we run diagonals through the box, and these are like asymptotes. They kind of hold in the swoops, or like the u parts of the hyperbola. And then these points on the rectangle, these midpoints, this is where the hyperbola is going to touch this box. So if x was first, this would open right and left. And if y is first, it opens up and down. So in this case, this is a vertical one. It opens up and down because y is first. So this is the bottom of the parabola, or well, the top part of the parabola, which looks like parabola, but it's part of a hyperbola. And it's contained within these diagonals. And then this is the bottom part. It hits the edge of the rectangle and opens down and is contained within the diagonal. So that's an example of how to graph a hyperbola.